There is a persistent and highly marketable illusion dominating the modern firearms industry. It is propagated by flashy advertising campaigns and sponsored individuals who prioritize the aesthetic coordination of their tactical nylon over mastering fundamental marksmanship. This illusion insists that true reliability can only be purchased for several $1,000s, taking the form of a custom machined rifle boasting a half-minute of angle guarantee, titanium internal components, and skeletonized receivers. Let us speak frankly. Drawing from a lifetime of studying military history, observing the mechanical failure points of complex weapon systems in austere environments, and understanding the uncompromising reality of combat, when supply chains fracture and you can no longer order proprietary replacement parts with next-day shipping, that expensive, tightly toleranced rifle is often one broken extractor or fouled gas ring away from becoming nothing more than an intricately machined paperweight. True longevity is not found in boutique race guns. It is found in time-tested platforms engineered to function with surgical precision despite a profound lack of maintenance, adverse conditions, and inconsistent ammunition. Today, we are examining 5 mechanical masterpieces that are frequently overlooked because they lack a lucrative profit margin. We will evaluate firearms that can still be acquired on the secondary market for right around $300. By the end of this broadcast, I will elevate one specific action to the pinnacle of this list, a design so flawlessly executed to solve a fatal feeding issue that modern mass production facilities can rarely afford to replicate its mechanical perfection. Welcome to Gun Sage. If you value historical heritage and mechanical authority over hyperbolic sales pitches, you are among peers. Before we delve into the heavy-hitting center-fire cartridges, we must address the fundamental logistics of subsistence and evasion. To do so, when we look at what is arguably the most proven rimfire platform in existence, the Sturm Ruger 1022. It is easy for armchair theorists to dismiss the .22 long rifle cartridge as insufficient. Such dismissals usually come from individuals who have never studied the logistical constraints of long-term survival or the medical realities of small-caliber wounds. For less than $300 new, and significantly less on the rack, you acquire a platform built on a masterfully simple blowback operating system. There is no delicate gas tube to clog with carbon, and no multi-lug rotating bolt to seize. Instead, a dense steel bolt is held securely against the breech by precisely calculated spring tension and the sheer mass of the bolt itself. Upon ignition, the rearward pressure of the expanding gases must overcome this resting inertia. And this critical delay allows the 40-grain projectile to exit the 18.5-inch barrel, permitting chamber pressures to drop to safe levels before the casing is ejected. The metallurgy of that barrel is equally impressive. Utilizing a cold hammer forging process, a massive industrial hammer physically forces a steel blank around a carbide mandrel bearing the reverse image of the rifling. This violent compaction aligns the molecular grain structure of the steel. We're resulting in a remarkably durable bore with a standard 1 in 16 twist rate. Out of this barrel, a standard high-velocity 40-grain solid bullet achieves roughly 1,200 feet per second. However, the true tactical advantage emerges when transitioning to subsonic ammunition. Pushing that same bullet at approximately 1,000 feet per second entirely eliminates the supersonic ballistic crack. The ability to harvest small game quietly, without telegraphing your position to anyone within a 2-mile radius, is an invaluable capability. Furthermore, an individual can easily carry 500 rounds of rimfire ammunition in their pack, adding a mere 3.5 pounds to their loadout. But the true mechanical genius of this platform lies in its rotary magazine. Prior to its introduction in the 1960s, feeding rimmed cartridges from a standard box magazine was a notoriously unreliable affair. And as the rims would inevitably overlap and lock together, Sturm Ruger engineers designed an internal sprocket system that individually cradles and separates each cartridge, feeding them flawlessly into the chamber. It is an uncompromising solution to an age-old problem. While we are discussing the physics of rifling, I have a ballistic question for the seasoned marksman in our audience. Please provide your answer in the comments. Once and I will address the mechanics of it shortly. If you are comparing a barrel with a 1 in 7 twist rate against a barrel with a 1 in 12 twist rate, which of those two is mechanically required to stabilize a remarkably long, heavy projectile in flight? And what is the physical principle behind that requirement? We shall see who truly understands exterior ballistics. Moving up the spectrum of caliber and capability, we encounter a modern anomaly in the world of precision manufacturing. The Savage Axis, specifically the earlier base models, is frequently dismissed by purists due to its flexible polymer stock and a factory trigger that typically breaks at a heavy 6 to 7 pounds. However, beneath those superficial budget constraints lies an action of extraordinary mechanical ingenuity. For roughly $300, particularly on the second-hand market, you can acquire the 308 Winchester variant and tap into an engineering philosophy that dramatically reduces manufacturing costs without sacrificing surgical precision. In traditional, highly expensive bolt-action rifles, the bolt is a single, rigid piece of machined steel. For that rifle to be accurate, the receiver threads, the locking lugs, Savage circumvented this expensive requirement decades ago by designing a floating bolt head. When the bolt is pushed forward and the handle is turned, the separate bolt head is allowed a minute amount of articulating freedom. This allows it to physically self-center and square itself perfectly against the cartridge datum line within the chamber, ensuring perfectly even pressure upon ignition. This brilliant piece of engineering is paired with a proprietary barrel nut system, allowing factory technicians to set the headspace to absolute, exacting minimums before locking it down. The result is a lockup that mimics the consistency of a custom bench rest rifle. The standard 22-inch carbon steel barrel utilizes a button-rifled bore with a 1 in 10 twist rate. In this relatively fast twist is explicitly tailored to stabilize a wide spectrum of 308 projectiles, from economical 147-grain military ball all the way up to heavy 175-grain match hollow points. At a remarkably light 6.5 pounds unloaded, it absorbs felt recoil surprisingly well through stock flex, while retaining the capability to hold a 1 minute of angle group, exactly 1 inch at 100 yards. In with quality ammunition, it is a highly capable defensive tool wrapped in an unassuming package. Now, let us shift our focus to the brutal realities of 20th century warfare, where neglect, mud, and continuous exposure destroy delicate machinery. When examining historical footage from the jungles of Southeast Asia or the urban decay of modern Eastern European conflicts, one rifle consistently emerges from the rubble in functioning condition: the SKS. While pristine Russian Tula models have become expensive safe queens, the heavily worn Chinese Type 56 variants can still be sourced in local pawn shops for a very reasonable sum. Designed by Sergei Simonov in the closing days of the Second World War, this rifle is a mechanical juggernaut. It was explicitly built to be operated by poorly trained conscripts in the most unforgiving environments on the planet. The heart of its reliability is its short-stroke gas piston operating system. Modern direct impingement platforms vent hot, carbon-fouled gases directly back into the receiver to cycle the action, which requires rigorous lubrication and cleaning. The SKS, by contrast, taps a small volume of gas near the muzzle, directing it into a dedicated cylinder where it violently strikes an independent operating rod. And this rod transfers the kinetic energy to the massive bolt carrier, sending it rearward. Because the gas itself never reaches the internal action, the receiver remains incredibly cool and free of carbon buildup. Lockup is achieved through a robust tilting bolt mechanism. As the heavy carrier travels forward, it physically forces the rear of the bolt downward into a substantial locking lug that is milled directly into the solid steel receiver. It is a primitive, heavy design, but it is virtually indestructible. To further enhance its longevity, the 20-inch barrel of the Type 56 features a heavily chrome-lined bore. This complex, toxic electroplating process deposits a hard layer of chromium throughout the barrel and chamber, rendering the steel highly resistant to rust, jungle moisture, and the highly corrosive salts found in cheap surplus military primers. Firing the proven 7.62 by 39 millimeter cartridge. A standard 123 grain projectile departs the muzzle at 2,400 feet per second, yielding the kinetic equivalent of a 30-30 Winchester. The rifling twist rate of 1 in 9, 45 inches guarantees a practical, combat effective accuracy of 3 to 4 minutes of angle. Furthermore, the rifle feeds from a fixed, integral 10 round box magazine loaded via stripper clips. In an unpredictable environment, the elimination of fragile, easily lost external magazines is a profound logistical advantage. Regarding our earlier ballistic inquiry, the correct answer is the 1 in 7 twist rate. A faster twist, which completes one full rotation in 7 inches rather than 12, imparts a significantly higher rotational velocity to the bullet. Long, heavy projectiles, such as a 77 grain match bullet, have a center of gravity that requires this aggressive gyroscopic spin to remain stable in flight. Firing that same heavy bullet from a slow one in 12 barrel will result in the projectile tumbling end over end and keyholing the target. Understanding your twist rate is just as vital as understanding your internal ballistics. Next, we look at a rifle that has been the subject of countless jokes regarding its crude aesthetics, yet commands immense respect from seasoned armorers for solving a massive engineering hurdle. The Mosin Nagant, specifically the ubiquitous 91 and 30 or the shorter M44 carbine, remains a testament to brute force reliability. When Sergei Mosin and Leon Nagant designed this action in 1891, they were forced to chamber it for the Russian military's chosen cartridge, the rimmed 7.62 by 54R. Feeding rimmed cartridges from an internal box magazine reliably is a metallurgical nightmare, as the rim of the top cartridge can easily slip behind the rim of the cartridge beneath it, resulting in a catastrophic malfunction known as rim lock. Other nations relied on their soldiers to carefully overlap the rims when loading their stripper clips. The Russians, understanding the chaos of combat, engineered a mechanical failsafe. They designed a separate, complex, spring-loaded component known as the interrupter ejector. This finely milled piece of steel sits within the receiver wall. When the bolt is manipulated, the interrupter physical depresses the second cartridge in the magazine, holding it down and away from the top cartridge. Because the top round is entirely free-floating, rim lock is mechanically impossible. It is an intricate, highly demanding machining process housed within an otherwise heavy and agricultural weapon. From the 29-inch barrel of the 91 and 30, utilizing a 1 in 9, 5 twist rate, a 147 grain bullet reaches velocities of 2,800 feet per second, delivering over 2,600 foot-pounds of energy. The heavy 9-pound weight of the rifle serves a vital purpose, acting as a physical dampener to soak up the punishing recoil of this massive cartridge. While the trigger pull often stacks heavily and the bolt requires significant physical force to cycle once the action heats up, its ability to tolerate freezing mud and total neglect is legendary. This brings us to our number 1 selection. If we are to crown a single firearm that embodies the absolute pinnacle of mechanical perfection, historical heritage, and uncompromising reliability for roughly $300, we must look to Paul Mauser's masterpiece. I am referring to the sporterized Mauser 98 variants, the countless Turkish, Spanish, and Yugoslavian surplus actions that were modified by domestic shooters decades ago. While pristine German examples are relegated to museums, these heavily worn workhorses are the gold standard of survival tools. What you are acquiring is the legendary controlled round feed action. The inherent flaw of a modern push-feed rifle is that the bolt simply shoves the cartridge forward. If the operator short strokes the bolt under adrenaline-induced stress, or attempts to cycle the action while upside down or moving aggressively, the rifle can easily induce a double feed, jamming the action entirely. Paul Mauser eliminated this possibility in 1898 by designing a massive, non-rotating claw extractor made of tempered spring steel. The moment the bolt pushes a cartridge forward from the magazine, the rim of the brass slides up and securely under this massive claw. The cartridge is firmly gripped against the bolt face long before it ever enters the chamber. It is held in a vice-like grip during chambering, firing, and extraction. You can cycle a Mauser 98 upside down, sideways, or flawlessly under the highest levels of physiological stress. Many of these surplus actions, particularly the Turkish model 1938 variants, remain chambered in the devastating 8 by 57 millimeter Mauser. Firing a 196-grain, full metal jacket out of a 24-inch, stepped contour military barrel, the projectile achieves 2,500 feet per second, generating over 2,700 foot-pounds of kinetic energy. It possesses the penetrative capability to completely dismantle an engine block or humanely harvest any heavy game on the North American continent. The action itself is forged from robust, early 20th century steel alloys designed to handle immense pressure spikes. While ancient surplus ammunition may yield a 3-minute of angle group, defeating these actions, modern soft-point ammunition frequently tightens that dispersion to a highly respectable 2 inches at 100 yards. It is the ultimate insurance policy against mechanical failure. The defining lesson here is one of perspective and mechanical reality. We exist in a commercial era that attempts to substitute genuine competence with expensive accessories. A perfectly machined, $3,000 race gun in the hands of an individual who cannot read wind drift or understand their ballistic drop is simply a liability. But a battered Mauser 98, an ugly Savage Axis, a rugged SKS, or a quiet 1022 in the hands of a man who rigorously maintains his gear, understands exterior ballistics, and relies on the fundamentals of marksmanship is an incredibly formidable force. To true survival relies on redundancy and the proven mechanical tolerance of time-tested steel. I want to hear from the veterans and the mechanical purists in our audience. You are the men who have turned wrenches, operated reloading presses, and carried steel and wood through the most austere environments on Earth. Go to the comments and detail the most battered, inexpensive firearm you have ever relied upon that refused to quit. Share your field repairs, your load data, and your real-world observations. We are building a repository of hard-earned, uncompromising truth. Keep your powder dry, respect the mechanics of your tools, and I will see you on the next broadcast.